the formula. There's various expansions of determinants, and one of them is you can see that the determinant of the 2 by 2 one here of A, B, C, D is equal to AD minus BC. So it's like the AD minus this term here. Well, I'm going to show you there's a formula, similar formula for the 3 by 3 matrix, and that's all we'll need. The point is that when we deal with eigenvectors and eigenvalues, we need to take the determinant of a matrix with a variable. Because of that, the numerical method isn't so useful because you have to carry along this you can still do it. And it may actually be, in some ways, possible to do, but then you have to have various cases anyway, so we can examine that. But let's say, so it turns out that we can write this determinant as, it's called a cofactor expansion. So we do is we sort of think of this first, we sort of label minus plus, and you can think of this as plus, minus, plus. These are going to be signs. So we can expand along any row or column. Let's say we expand upon this top row. That means we're going to have 3 2 by 2 matrices. So we choose, say, first A. We do this with colors. Orange. So we'll start with A, and then that's going to give us, we'll have A times the determinant of E, F, H, I. Okay? Then we take the sign here, if we're expanding along this top row, minus B with the determinant of this column and this one. See, with A, I left off the first row in the first column. With B, I leave off the first row in the middle column because it'll be B times the determinant of D, F, G, I. See? D, F, G, and I. Then the last term is going to be C. That's plus C. So it alternates plus, minus, depending on the size, times the 2 by 2 determinant of leaving off the first row in the last column, D, E, G, H. So then we could write this as A times E, I, minus F, H, minus B times D, I, minus G, F, plus C times DH minus GE. Well, except for the color here, which is fine. That's the formula. So, it's useful sometimes to use this in that case. Now, usually we'll end up with some zeros here that will end up making this simple. But this is actually the formula that you would get if you could derive this formula from using those principles because it's unique. This is the only number it can be. Anyway, but this is just this expansion that's well known, and so if you need to do determine a 3 by 3 matrix, it's a little bit tedious. You just have to remember how to do it. And oftentimes, though, you can find a row that has lots of zeros. Like if these weren't 0, but D and G were 0, you could do a cofactor expansion down here. Then you'd have A times D times G times the determinants. But since D and G are 0, you'd just have this first one. And that simplifies things. Or if you had sort of some zeros over here, you could do the same thing of expanding along a different column or row. So generally, expanding on the column or row that has the most zeros will simplify things. So if the matrix, unless the matrix just has all kinds of big numbers everywhere that aren't 0, in which case the gaseous method would work. This one you can often be crafty and use this formula to get there quickly. Okay, well, that's the, I think it's the cofactor expansion of determinants.